everyone. This video lecture is going to cover Chapter 6 on 2D graphics. This is a really fun chapter. Learning to plot in MATLAB is actually, not only is it really useful, but it's actually kind of fun too, because it really demonstrates kind of all the different capabilities of what we can do in MATLAB. So there's quite a bit to the chapter, but it's really not that complex. So it looks like there's a lot here, but don't worry. We're going to go into some basics of 2D plotting commands, and then graph annotation and enhancements, and then there's some examples which I will of course do in our next video. So the objective is just to introduce you to MATLAB's 2D plotting capabilities to include graphics management, curve and surface generation, annotation, and graphics. So this slide here just shows you some of the basic plotting functions and commands that we have available, and that's whether we're plotting in 2D or 3D graphics. So Chapter 6 covers the 2D graphics. Chapter 7, we're going to go into the 3D graphics. But this just gives you kind of a nice summary table of the different commands that we have available. So we'll start here with the graph management. A graph is created in a figure window, which is basically just another window that's opened up in MATLAB when you execute a plot command, when any one of its graph management, generation, or annotation and characteristic functions is invoked. So when a script or function uses one or more graph generation functions or commands, then MATLAB creates a new figure window. So what that means is when you execute a plotting command in MATLAB, let's say you have two different plots, it's going to close the other one and open the new one. So we have this figure function that we can use, and what you put in the input arguments for n is your figure number. So if you have 3 different graphs that you want to open up when you execute your code, then you would do figure 1, the plotting expressions, figure 2, plotting expressions, figure 3, plotting expressions. So that just kind of gives you the syntax there. If the argument of figure is omitted, then MATLAB gives it the next integer value. You can also place several independently created graphs into one figure window, and we have a couple of ways of doing that. One of those is to use the subplot function, and you can see the input arguments here are I, J, and K. So I and J divide the window into sections of rows and columns, and then K indicates in which sector the graph is to be placed. So a value of 1 for this argument indicates that the upper left corner is where the graph should be placed, and the product of the number of rows and columns indicates the lower right corner. As the numbers increase, they indicate the sectors to the left or right starting at the top row. Any annotation and management functions that appear in the program after figure and or subplot only apply to that sector indicated by the third argument of that subplot function. So in this case, we're referring to that K value. Within each sector, any compatible set of 2D or 3D graph generation functions can be used. So this gives you an example here of what it looks like when you use that subplot command. So this top example here, we've created figure 3, and then subplot and subplot. So if we use subplot here, 2, 1, so that's indicating 2 rows by 1 column. So you can see here there's 2 rows, but there's only 1 column of sections. And then the 1 here indicates the top section. The 2 here indicates the bottom section. So then we look at figure 4 example here. So now we have a bunch of subplots. There's 6 that we've created. So you can see again, it's 2 rows by 3 columns. So now we have 1, 2 rows by 1, 2, 3 columns. And if we wanted to use this section right here for our plot, then we would put a 3 for that K value. Similarly, for the second one here in the top row, we'd place a 2. Here we'd place a 1, and then so on, as you can see for the bottom rows. Since each graph generation function creates a new figure window, in order to draw more than one graph, surface or line, or any combination of those on a given graph, you have to use this HoldOn function. And what that does is it basically holds on to one graph and places it on another graph. So if you have two graphs that you want to have on the same exact window, then you would use hold on between the plotting commands for those. All figures that have been created can be copied to the Windows clipboard by selecting the Copy Figure from the Edit pull-down menu within each figure's window. This figure can then be transferred to a page in a word processor, such as Microsoft Word, and it'll be in the Windows meta file format. So the basic command that we use to plot in 2D in MATLAB is this plot UVC function. And I don't know why they use U and V. To me, it makes it a little more confusing. But U and V just represent the X and Y coordinates that you're plotting using this function. These points are either a pair of numbers, vectors of the same length, matrices of the same order, or expressions that, when evaluated, result in one of these three quantities. The quantity C is a string of characters, and these characters specify the formatting of that plot. So, for example, if we were plotting a point, then the C expressions would be a string of characters that we can use to format that point, whether it's an open circle, a closed circle, if it's we can format different colors for those. So one character specifies the line point color, one character specifies the point type if points are to be plotted, and then one or two characters are used to specify the line characteristics. The order of these three sets of characters within the single quotes is not important. So you could specify the color before you specify the point type. If the C is omitted, then the system's default values are used, and if more than one curve is drawn, then the line colors change according to the default sequence. So where this is going to be useful is there will be times like when we're using different methods to plot ordinary differential equations, you're going to end up with two of the same exact graphs on the same graph window. Well, the only way that we can distinguish that both plots are actually on the graph is to change the formatting of each of the graphs so that we can change the color or the point type or the line type so that we can distinguish the two from each other. Positioning one figure inside of another, that's something else that we do have the ability to do. To insert a figure within a figure, we use this axes syntax here. So position, this is just a keyword that you're going to have to use, and then left, bottom, width, and height are specified according down here. So left is your X coordinate of the figure origin. Bottom is the Y coordinate of the figure origin, and then width is the width of your figure, height is the height of your figure. So as you can see here, if we're trying to position a figure inside of a figure, we could specify the left and bottom, which is the X and Y coordinate of the origin of the figure, and then the width and height that we want that figure to be. So for example, if we specified those, we could insert a figure up here in this top right quadrant. Animation is something else that we can do in MATLAB. This is going to be really cool. I'm going to show you guys the example in the next video where we're going to animate a slider crank. It's actually pretty simple to do in MATLAB. So the two functions that are used to create a movie are this get frame. So you have this subscript notation A of K, which captures the kth movie frame of a total of n frames. So you do that, and then we have this movie function where the input arguments are A, the NF, and BPS. So this function is used to play NF times the n frame captured in a matrix A by get frame, this function up here. This function plays the movie at a playback speed of PBS, which if omitted uses a default value of 12 frames per second. So to create a movie in the AVI format, we can do that using this movie to AVI. So this basically just transfers it to an AVI for us. So here is our matrix of values or whatever. And then you see we can create the file name .avi and then keyword and keyword values. So variable A is again the variable used in movie to create movies that can be shown, for example, in these PowerPoint presentations. For this keyword here, we could say compression. And then keyword value is none. There's additional parameters. If we look at the help feature for this particular function, then it provides us with some additional options. So again, here's the example that I'm going to be doing in the next video for the animation of the slider crank. It goes through, we have the code here available, so you can also go along and do this with us. It's going to be really neat. So you can see it goes on for a couple of pages there, but in the end, we're going to end up producing this in MATLAB. So if you have any questions, let me know. Otherwise, I'll just see you guys in the next video. Thanks so much. Bye.